I'm Leif. I work at Fraunhofer and I'll deal with mixed and augmented reality stuff. And I'm going to tell you about who we are just very quickly so you get a background, and then what we did and maybe what you can learn from that, hopefully. So there's some study hidden in the presentation. So Fraunhofer FIT is not the Fraunhofer Institute. It's one of 72 Fraunhofer Institutes. And we are concerned with human-centered design and cooperation systems. Maybe you know the MP3 compression format. That was a very famous invention by Fraunhofer IIS. So we are there and doing innovations for industry. We are located in Institute Center at Castle Billinghof in St. Augustin near Bonn, which is one of the oldest German IT centers since exactly 50 years. So we had a big jubilee this year, and we're also doing 20 years of AR, MR, XR or whatever. 50 years of research in this area means we have got an old building that needs renovation. That's the hinge I'm going to use for this presentation. Just to get you on the same page where I'm coming from, we saw a lot of AR stuff going outside in the last 2 decades, basically, and our work was no exception. So we started with something in an augmented room. On the top left, you see a typical EU project where architects were designing about building models. In this case, it's the London Gherkin from Norman Foster, and Norman Foster was also part of the project. Well, not himself, but the company. And so how could you make AR models more approachable to architects before it was kind of turned into plywood or styrofoam models? That was the idea of the project. Then we took it into the building. So from this specially prepared room into whatever room it has been kind of entered into the database. So the user on the lower left side is wearing some goggles, monoscopic, and has a PDA, if you remember that, and that's connected over the internet, and he could hold augmented reality chats with a colleague if there was a problem with something not being built to measure or something like that. Then we had a range of projects in the gaming domain, very popular. Like many others, we had large EU projects called iPerk and also IP City. iPerk had many different gaming showcases, and one of them was the Epidemic Menace, which is shown in the top right, which was played on our campus for 2 consecutive days in 2 years following each other. And one of the interfaces is a big, giant Ghostbuster-like mobile AR thing that destroys viruses which were spread according to weather conditions and so forth. So all the different interfaces were linked into one. And then we gradually moved that into the city, which was the IP City time warp use case you see on the lower right. And you could say that Pokemon Go is a descent of that, although we are not involved with that. So once we went outside, this was caused by the devices getting increasingly powerful and smaller and so forth, and all your smartphones that you're holding in your hands are much more powerful than what we had when we began researching this kind of stuff. We thought we're going to have better sensors and more computing power, and we make it a mobile kit, but not portable as a mobile phone, so something you could put on a rig or onto a car. And hence the Auto AR project was born, which we used to visualize, for example, headquarters, like in this case from Fiducia. And we could do that with little effort and centimeter precision, so we can make architecture visualizations on the spot without having the models of the surrounding buildings, which is really the difference. So you could, of course, just visualize those buildings on their own on any kind of display, but you couldn't visualize them in relation to the trees and to the neighbors, which you don't have the models from. So that was presented last year here at Augmented World Expo. If you want to check that, there's a video behind that QR code. With that under the hood, our own renovation phase approached. And, actually in parallel, but our building needed to be renovated. 50 years ago, we didn't have CAD, let alone 3D CAD. But luckily, we have our own real estate office and own architects. And so the first task for the architect was to model all the buildings according to what has been there 50 years ago. then to what has been there when the renovation started, and then what will be there when the renovation is finished. So architects like to work with this kind of variation. So there was a lot of work involved, but the full campus is there in 3D. Wonderful for researchers, and you can see a little visualization just with the game engine in the middle picture. And we have interior models. We've got the kitchen model, which is built like that. And you see, for example, a floor print of the space where I'm working. And the architect is also just showing that to the lady up there on the screenshot. So we got everything, including material data, not in the sense of perfect ray tracing pictures, but carpet, wall, plywood, whatever, this kind of material. And that's the level of granularity also the architects wants to have. So they said, we're not going to modify my model, please. I put thought into how I wanted to have my materials. So that's our floor plan. One round is about 100 meters. And it's a really unique opportunity for researchers to work with that because we had everything in place. We've got the technology, we had the experience, and our own building was renovated, and we got all that data. So we've got all the rooms and also all the supply engineering data. So for example, the pipes, if you see the little green arrow there, I have a video for that in a minute. You see how you can look through the wall and see the pipe works. That's the actual data, so no game data. So based on that, we designed a couple of theses and little projects just to investigate different aspects, so different application domains and also different devices. And we did, of course, indoor tracking, so that's available on a couple of devices, and user acceptance studies. And I want to give you some insight of what we've learned from one of our studies. But maybe just a quick screenshot of how it looked like during the construction. So that's just a 360 photo. That's our new coffee room. You're going to see later how it looks like now. Even in this phase, we already had, of course, the full model. Everything has been planned already, and we could showcase it to people in a normal VR set. So we could just bring an HTC Vive and a game engine and put everything in there, prepare it a little bit, and take people on a tour, anywhere we wanted to.
Was ich gerne zeigen möchte, ist hier der Kernbereich oder den Meeting Point und Teeküche, wo wir jetzt noch hier in dem alten Bestandsplan Lüftungen drin haben, die oben auf der Baustelle schon abgerissen sind.
The architect and the developer showcasing what they had built.
Auch hier die bestehende Zuluft und auf der anderen Seite die bestehende Abluft und hier diese zusätzliche Verbastelung, die wir jetzt zurückgebaut haben.
So the red were ventilation pipes, air in and out.
Zur Decke gehen und in den Transparentmodus schalten. Dann sehen wir auch noch hier dieses Stück von der alten Lüftung, die hier jetzt lila ist, die in den Raum von der Klimazentrale geht und deswegen hier auch diese vielen Rohre, die wir jetzt durch die Wand sehen, weil hier in dem Raum befindet sich halt die ganze Klimatechnik und die Rohre, die auf dem Modell blau sind hier schwarz.
So yeah, job done. If you want to check the video later, I think this is being recorded at the moment. I'll put a link to the video in the Twitter that's linked to the speaker page here at all. So empty rooms, all the building models really nice. Furniture is missing. So Luckily, we also had all the 3D models available because our architects were so kind to give it to us. And that provides a good basis for spatial reasoning. So we wanted to check out how well can we talk about 3D models in the actual room, and how well can people reason about that. And we've done that in cooperation with Vario. On the left side, you can see the construction site that you just saw on the video, already superimposed with the 3D model. Based on our previous work, we didn't put any extra effort into making it look super nice, because it's going to be a 3D model and we want people to recognize it as 3D models, but still it should look okay. And on the right side, that's not a rendering, that's the room as it has been photographed afterwards. This is just a little impression for you how the furniture looks like when you look at it through a tablet. So that's coming here. It's actually a different room, it's the room next to it. And you can just walk around and check out everything that's been planned. Right. Okay, so that's a nice study setup for us. So we thought, okay, let's try out what we can do with that. It's a realistic scenario. It's a real building that undergoes real construction and has just been refurbished, and no one is in it yet. So you can see it's kind of an empty space. So it's no longer on construction site, so it's legally safe for us to enter it with participants. And it's not yet occupied by everyone who's living there. So it was a time frame of about 1 week where we could conduct that without incurring any additional costs. We had all that beautiful data, and we designed collaborative tasks about moving furniture around and making decisions of placement of stuff, and also drilling holes where you would fit something without hitting pipe works and stuff like that. So making decisions based on 3D visualizations in the spot and discussing placements of stuff. We've done that with HoloLens. You see that in the picture on the left, and also with the Tango tablet. You've seen that in the previous videos. And we wanted to find out which one is preferred. Everyone has their feelings and preferences, but can we find something in the data that gives us some kind of evidence for this particular tasks in this particular setting? And let's have a look. We had 16 participants, which we always paired up in groups of 2, so you could make a decision together. That's more meaningful. They were architects, researchers, and student assistants. It's Computer Science Institute, 14 male, 2 female. And but 10 people were unfamiliar with the devices, so we didn't take the entire group of people working with augmented reality, but tried to source people from all of the institute. The 4 tasks were split into having to do 2 on the tablet and 2 on the smart glasses, so on the HoloLens. We had questionnaires in between, just very quickly. When you kind of put off the glasses, you got a questionnaire. When you put down the tablet, you got a questionnaire. We also got interviews, so to capture stuff that we maybe didn't think of in the questionnaires. We also had live observers taking notes and video observers, and a test run would be about 30 to 45 minutes. So that's results from a paper. I'm just going to talk you through on some of the highlights. On the left, you've got Tango. On the right, you've got HoloLens, and we've got comparable questions. Last one, which is only for HoloLens. So if you look at the top left smiley, the question was, in my opinion, planning an interior design with the help of an application on this kind of device, so Tango or HoloLens, received the perfect score, 16 on the Tango. Not so perfect on the HoloLens, so there was some trouble, and they only gave it a 2.5 instead of a 1.0. So that's how you have to read it from green to red. Also, people who use the Tango would recommend using the Tango to other people, or tablets, not necessarily only Tango. And for the HoloLens, the score again is quite significantly worse. So you have to pay attention to that. Just for the HoloLens is the next dash here. The 12 red, people were saying that the field of view is too small. Okay, granted, it's for economic reasons, something got to give, and we all know that it should be bigger, but we also have to be able to pay for these things, and also technology will advance. So we were just testing if people were having the same impression than what everyone is talking about. Luckily, people thought it's more intelligible if they look at the 3D representation than just looking at the floor plan. Not everyone agreed, but you see a significant green weight on the left side. We don't know who was giving the not so much score. Well, maybe it was the architect, maybe not. It was anonymous, so we didn't take account of that. Quite importantly, if you look at this little dash over here, the collaboration score. So I was able to collaborate well with my team partner is really, really bad with the HoloLens setup. It's for different reasons. It's a co-located setup. Maybe the HoloLens is better for remote collaboration and not so great when you do the round trip and talk to each other, and you've got all this big delay, which you also see on the other demo in this room here. So people thought they could collaborate better with other people using a tablet, so just show it to people and collaborate on that. Not too surprising, but quite significant. And also they noted that they were not so much fixated on the device when they were using the tablet, probably because they knew how to use a tablet. It's a familiar device, everyone has used one, or at least it's similar to their smartphone. Whereas with the HoloLens, not much so. It's kind of an awesome device, but not many people know how to use it. And yeah. So further results, just very quickly. You see Tango on the left column and the HoloLens. And so which implementation would you prefer? We just aggregated that from all of the different tasks and all of the answers. And it's quite significant that people actually clearly favored the Tango in our study setup. So for the task that we gave them in the implementation that we provided, it was the more familiar interaction and the notably more handy device, which is important, facilitates face-to-face communication. So if you want to speak to someone, you better don't have the HoloLens, in your face, or even worse, some kind of virtual reality glasses, things like that. We know that also from discussion with other partners. When they're in a sales meeting, they want to look people into the eyes. That's important, and that's a clear favor for the Tango tablet. Sadly, Tango has been discontinued, as many of you will know. But all is not bad. AR Core is there to the rescue, so that's the new thing, which is available in all the phones, and also as AR Kit, of course, on Apple devices. But AR Core doesn't support the area learning, at least not officially. So we'll see what the future brings. We tested the area learning just very quickly. I sneaked this in from another paper. You will remember that our building is kind of a rectangular shape, and you saw the floor plan earlier. It's actually symmetrical, and even area learning, if you look at the middle part, gets confused regularly and jumps to the other side of the building, so that's not so good. But technology advances that everything was going to be bigger and better in the future. And of course, these findings are for co-located applications as we've designed them. Your findings will differ if you do remote collaboration, and we've seen that also in the talk from Siemens earlier today. Based on that, so we started in an augmented room, we went outside, we went back inside, we had sophisticated 3D models that were handcrafted with love from 50 years old plans. Of course, not everyone is able to do that. I mean, that's something that we could afford and we wanted to afford. But maybe you don't have 3D plans for something older, like one of those buildings on this picture, and maybe you can't rebuild it from scratch, or you don't want to pay for that. How do you get your digital floor plan? So through a Fraunhofer program, we met a company called Voxelgrid. And they have a setup where you can just simply walk through with the custom gear through different rooms and capture the floor plan. I mean, they do LiDAR scanning and photogrammetry and so forth, and do lots of processing afterwards with deep learning and so forth. And then you've got a floor plan, and that's quite cheap. And based on that, we want to do augmented reality, or however you would like to call that. So. To be continued. That's my presentation, and if you have any questions, I'd be happy to answer them.
Very good, Leif. Thank you so much. We have one question over here.
Hi there. Blimey, it's loud. You mentioned that you could go in the rooms and move the furniture around, etc., and figure out layouts. Were you then able to write that data back into the CAD system for the designers, or was that just purely visual?
In theory, we could, but of course it's a prototype, so in that specific case, you couldn't. But we've actually done something like that in another project, where we didn't write back the modified cut position, if you so will, but annotations about those things. So there's an exchange format about making annotations in CAD, and so we basically built a location-based virtual reality, mixed reality issue tracker in the model. So I could actually say this laptop table needs to be there. And then that would pop up in the architect's workstation.
Right, okay, but you didn't actually move the model and write the data
No,
back?
you know, these programs that the architects use, they're really, really sophisticated, developed over the last 30 years and then bought by a single company. And we are not competing with that.